Dear students, very good morning. Today we are going to discuss about embedded file system in Unit 4, Embedded OS and Modeling. Okay, so let's discuss. So first we have to know the overview of embedded file system. The file system components uses used to embedded application to create, save, read and modify files in storage devices. What are the storage devices like random access memory, flash memory, then memory cards, USB memory device. It is the part of MDK Professional and MDK Plus. Okay, so in this diagram we have a driver and file system component. In drive we have a random access memory, NOR flash, non-flash, USB MSC, master storage class, SD memory card, file system code. These are the types of file system component and CMSIS driver, NAND, flash, MCI, SPI. These are the CMSIS driver components. Okay, so the main function of the file system component is used to allow your embedded application to create a file or to create or save a file or read a file. We can to save as a file. That means modify a file into the storage device. The file system component is structured as follows. A multiple instance. Instance means object. Multiple instance of the same storage device can be implemented. For example, you might want to have an two SD card attached to your file system. The file system core support thread shape operation and use an embedded file system EFS, NOR or SPI flashes or FAT file system, which is available in two variants. The long file name variant support up to 255 characters. How many characters? It support up to 8 to 55. 255 characters in long file name. Short file name variant limited up to 8.3 file name support. Multiple instance long file name, short file name. How to store a document structure. This user's guide contains the following chapters. Creating a file system application. It explains the necessary steps to develop a project containing a file system from scratch. So we have to develop a file system from the scratch level. File system examples are a good starting point for implementing your own storage device. We can implement our own storage device using a file system example. A theory of operation gives more detail on the basics of file system component. Function overview. Function overview lists the complete API applications peripheral interface of the file system component. The file system, we have to know file system component. It integrate with the ARM Advanced Risk Machine Standard runtime library and requires a CMISS or TOS, real-time operating system compliant or TOS. So it cannot be used with ARM micro library since this library does not provide the hooks for input-output file handling. Okay, so in this picture we can understand the file system structures from the developer's perspective. So file system component structure, we have a core and then configuration. From we can start from system file management, standard file input output, ARM standard, runtime library. So after that, finally we have a storage devices. System file management functions that manage file system and provide operation to format a drive and manage file and directories. So this is the function of system file management. It manages system functions. So that's why it is called the system file management. Next one is the standard file input output functions to perform input output operation on files such as what are the option operations we are doing in the input output means read, write and seek function. Advanced Risk Machine Standard Runtime Library is the ARM library. It has a standard C library with functions to manage file. Another one is FS config C, configuration file for general characteristics. That's why it is called a FS config C file system. fsconfigs.xs configuration file for the characteristics of each drive of media. Embedded file system is a property file system used on NOR flash devices. We have two types of devices, NAND flash and NOR flash. What is the basic features in this embedded file system? We have three types of organization: memory organization, allocation information, file names and content are stored in the fragments of variable size which provide optimal file access times. So allocation information is mainly used to reduce to a minimum allowing small data overhead. So this three things: memory organization, allocation information, file names and content is mainly reduce the time. So it increase the efficiency of the operating system. So memory organization. So concentrate on memory organization. Here we are using a NOR flash device memory, physically divided into sectors and blocks. NAND flash, it is divided into sectors or blocks. The file system component designate them as a block. Typically, a block size it means 64 kilobytes, which is also the smallest erasable unit. Next one is the free space. File name and content located on the bottom of the block rows in ascending order and contain file name and data. So now we are discussing embedded file system. Here how embedded files are stored in the storage device and how it is allocated or retrieved from the memory. So in this diagram, a flash block 0 and then flash block n is available. Okay, first it has a three concept: allocation information, free space, and file name and content. So it is started from 0, that is block 0 to block n. Each block has 64 kilobytes. Already we discussed. The final thing is allocation information. It is a region, it is located on the top of the block. So where it is located, allocation information is located on the top of the block and describe the block's content. So it consists of a block signature and file allocation information records which are written in a descending order. So in this diagram, we can see a file allocation information and file fragments of variable size. There's a block, it is the class block, it is block signature, free space and file allocation information is given here. So next we have to concentrate on the different terms, that is block signature. Each block contains a signature consisting of 4-byte information and determines if block is empty or erased, used, but more data can be written into fill. Okay, allocation information record. It has a three different and variable and file ID index. Okay, so in this program we can explain embedded file system very clearly. So struct for allocation. File allocation. F allocation means FALLOC. It defines file allocation. In file allocation, we have to mention unit 32 data type. It is and file ID and then index. It has the file allocation information is written when it is written when the file is opened or open for writing the file is closed. Okay, so next one is the file name. So how we can define file name in embedded system means in embedded file system a file name consists of maximum 31 characteristics. It is very important. How many characteristics? Maximum 31 characteristics. Directories are not supported. So therefore, any file name which contains a directory separated character such as a slash or backslash is rejected. We have to use only the character up to 31 character we can use in embedded file name. So what is the disadvantage? That means limitation of embedded file systems. The following restrictions are applicable to embedded file system. Maximum file name 31 characteristics. Minimum block size should be 512 bytes or more. Directories or folders are not supported. Okay students, I hope you understand what is the functions of embedded file system and what are the parameters used in the embedded file system, how we have to define embedded files. Okay, so now let's go for the assessment. What is embedded file system and what are the types, classify the different types of embedded file and what are the features of embedded file system. Okay, so thank you students, have a great day.